Well, hi, good morning. Thanks for joining me here in my shop. Hey, we were supposed to have a gigantic snowstorm here in the last 24 hours, and everybody got snow, but here in Aurelia, we got but a dusting. We got only a couple centimeters, maybe not much, or something like that. And everywhere around us got this much snow, or more. So, well, maybe I should agree with my wife and consider that a lucky thing. But I kind of look forward to the big snow. So, okay. So here we are with this radio again. I'm going to start investigating the questionable capacitors. There's 5 of them in here, I think, that could be considered questionable, or more questionable than the rest of the highly reliable capacitors. So there's 2 molded ones. The radio's not on right now. There's this one, this green one here. There's another green one identical to it, buried down deep in here. Those 2 look like they're both 0.1 microfarads. Then there's this one, sometimes referred to as a bumblebee capacitor. These are known for being unreliable. In this radio they look fine. And I'm not anxious to change these parts, in fact, because the radio is functioning and it's all original at this point. So as soon as I change one part, it's no longer all original. So I'm hesitant about doing this. So there's 2 more capacitors down here that are electrolytic. In the service manual, this is a single 2-part capacitor, an 8 and a 4 microfarad capacitor. In my radio, it's 2 separate capacitors, and I'm pretty sure it's original. I don't think they've been replaced. So these ones are of particular interest to me. This one is a bypass capacitor, 4 microfarad bypass capacitor on a cathode resistor. And this one is hooked up to the antenna relay switch, and I suspect it's to make the relay operate without some kind of trouble. Okay, and the trouble could be everything from a spark when you open the gap, which I don't think is the problem here, or making the relay close and open without chattering, or something like that's going on. I'm not exactly sure, so that's why I want to explore all these. And I think I might even start with this one that's hooked up to the relay, since that's the most unusual application of a capacitor for me. Why don't we take a close look in there and see what we can see. Okay. See a lot of red wires hanging around there. Get my camera steadied up. Improve the focus on it here. Okay. Let me just swing a few of these wires out of the way. 8 microfarads. I'm going to guess it says 150 volts just beyond there. One end grounded, positive end connected to what? So I'm trying to see if this connection goes to the coil or goes to the actual relay switch. Sure looks like it's going to the coil. I mean, I'd be surprised if it isn't. If this is a coil wire, then this is a coil wire, and I see another wire coming to this point because the where's it coming from? So there's a wire coming off of this terminal. It shoots around behind the relay, and I believe it's among this bundle of black wire over here, but it's just out of the view of the camera. So it's, of course, hard to see black wire, but there's a bunch of black wire in here. So I think basically you've got 2 leads coming from the relay heading this way up into the radio somewhere, and on one lead is this big capacitor to ground. So one lead to the coil is grounded. That's what it looks like to me. Now look, clearly this is the output here. This little black cable goes right back to the antenna connection. The grounded shield, and then there's the live one, and it's hooked up right to this. piece here, which in turn is the piece that actually moves on the relay. And so as it moves, it selects either the top connection or the bottom connection. Energize the relay, it goes down, and the bottom connection is to the transmitter output, the upper connection is to the receiver output. So I think I got all that quite straight. But to kind of really see what this capacitor is doing, I think I want to look on the schematic and just take a look at this relay. It's shown in a, I don't want to say strange way, but it's not the easiest thing in the world to look at. So let's do that. Okay, so here is the schematic. Here's the relay right here. Zoom in on it. 200, probably indicating the resistance of this coil. Is it 200 or 2? Well, we'll assume it says 200. And here's the 8 microfarad. See, it says C28B, but in my radio, it's not an A and a B. There's another 28A in the schematic, but in my radio, it's 2 separate capacitors. But they certainly match in value, though. So we have an 8, right, just as I said, right on the coil. It looks like the cathode current from the amplifier is fed through the relay. Really? And then it comes down over to another cathode. Okay. Well, that's what it looks like. It looks like this is in the cathode circuit. What's this wire here? Up to the transmitter. So this switch is basically applying this ground to either of these terminals. So if you switch it to transmit, this is grounded out. Looks to me like it's activating this tube here. Grounded out. I'm not going to be able to analyze this properly. Grounding this. You put a ground on this, and you're now pulling current through this relay. Unless this, oops, oh, sorry. Unless this is on, oh, I read this wrong. What did I say? You're pulling a ground? Here we are. This is the one. This is the switch on the microphone. So you switch to transmit. You're applying a ground here. Like I said, it was turning on this tube. Put a ground here. You're pulling current through this relay. That's what it looks like to me. Turning on this tube, which is amplifying the microphone. This tube kind of, it's like a two-part switching tube, sort of. This part is doing the audio coming from the radio. I think it's coming down through here somewhere, I don't know. And this part's doing the part from the microphone. That's kind of obvious how that's hooked up. And it's one or the other, the t'other being cut off somehow in the meantime. So if we study this long enough, we'd probably see how to do it. Or it's written in the manual, the theory of operation, describes some of this stuff. So what's the purpose of this thing? Like, what happens if you didn't have this here? What would happen if you didn't have this here? Well, one thing is, this relay would be faster on the pickup and faster on the let go. Maybe they want to slow this guy down a little bit. Why would they want to slow him down? They slow him down by putting this drag in the circuit. This thing has to charge up. You know, otherwise there's some RF in here. And this is coming from the power amp. No, really? Really? Okay, so here's a place for the RF to shoot the ground right here. Boom. But there could be a tiny tidbit coming up here. So maybe this is to get rid of it. Absolutely. This great big capacitor. So why wouldn't they make this the great big capacitor then? Notice this capacitor is hooked up right on the relay. It's not back inside the radio somewhere. It's right up at the relay, just like they've shown it here. So I wonder if it really is trying to knock something out of this circuit before it gets to the relay. It even strikes me it could be something that was added in later, you know, in designing the radio. They got to the point where they realized this relay won't work because of problems with RF or something. I don't know, just making all this up. So if you don't have this here, you have some RF in this coil. Well, this coil would become a radiator of RF. Well, I don't know. That's what it looks like it's doing. As for, it could be timing and slow down this. Now, does that make sense? Let's see. You activate the relay. Or let's put it this way. You don't activate the relay. You close this switch on the microphone. Now you've stuck a ground onto this line. This is now grounded right here. The moment you put the ground on here, what was there before? What was there before? Before it was grounded, it was, you know, I don't know. Yeah, I don't know. Okay, so I don't know the state of it exactly. And I'm wondering, is this thing already charged up? I don't know. How could it be charged up? If it's charged up, it's going to close this relay, so it can't be charged up. So you close the switch, this thing starts charging up, not enough current to operate the relay for some time. During that time, while you've left you know what, this is drawn, you know, I've got a mental image of when this is energized, this switch is pulled this way. Oh, what are they showing this? Is this always energized on receive, and then when you go to transmit, it releases? I don't even know. It's kind of what it's showing here, isn't it? So this is on receive. This is on receive. Nah, maybe they're just showing there's a relationship between this swinging arm here and this. Maybe that's all they're doing. So let's assume that when you energize this coil, it's the energization magnetic field of the coil that's pulling this over to the T, even though it sure doesn't look that way, does it? So upon closing this, sometime later, this comes over here. In the meantime, usually this doesn't actually make sense. In the meantime, the transmitters come live because the delay is on the relay. Transmitter's live now, and this thing is still sitting on receive. Could it be the other way? Could it be the other way? Well, no, it can't be, because when this applies the ground that energizes the coil when you go to transmit. So the energized coil switches on the transmitter, which makes perfect sense to me. I wouldn't design this the other way around and have this thing energized the whole time the radio is receiving. I don't think I'd want to do that. So, hey, you know what? I'll bet you maybe it's in theory of operation. Let's take a look at that. Let's take a look at the theory of operation, if I can find it now. Here. Yeah, once again, let me just pay homage to cbtricks.com, where I'm getting all this fantastic information from the manual here. So you can stop and read this if you like, but we all appreciate it. Okay, so somewhere in here is the theory of operation. Theory of operation, common circuit power supply, microphone switching. Okay, let's read this. An SPDT, let me get this a little bigger for you. SPDT switch on the ceramic microphone and controls transceiver operation in the following manner. Opens the cathode of the first speech amplifier VB10. That's that two-part tube I was pointing at. So microphone will not feed through the speaker. Okay. Grounds one end of speaker voice coil to place it in the circuit. Oh, in receive. In receive. Okay, in receive. I'm just reading this backwards. Opens the cathode of the first speech amplifier. So speech amplifier is the microphone amplifier, VB10. So microphone will not feed through. Grounds one end of speaker voice coil to place it in the circuit. Opens the cathodes of transmitter oscillator and amplifier V8 and V7, V8 to turn them off. So here we go into transmit. Grounds the cathode of the first speech amplifier, and we saw that. Applies a ground to that cathode. So the microphone will feed through to the second speech amplifier. Well, we'd have to study the schematic to figure that out. Grounds the cathodes of these two tubes through the coil of the antenna switching relay. Grounds the cathodes of these two tubes through the coil of the antenna switching relay to turn on transmitter, thus energizing this and transferring the antenna to the output of the transmitter. That doesn't say anything about any kind of delay or anything in here. But they're pumping all the cathode current through that relay. Grounds the cathodes of these two tubes through the relay. Rectified PA grid voltage blocks the grid of receiver's first audio amplifier. So that's how they shut off the receiver amplifier, if you like. V10 again. Keep audio from the receiver section getting out to the transmitter. Blocks the grid of the receiver's crystal oscillator to prevent receiving the crystal. Prevent receiver's crystal from oscillating. The same negative voltage passes through the diode switch D1 and charges the AGC line and opens a squelch. Oh my gosh, there's a whole pile of stuff happening here. Passes through a diode switch. So the way a diode switch works is if you reverse bias a diode and you try to pass a signal through it, it won't go through. And if you forward bias a diode, so there's a little current going through it, DC current, it will carry through a signal. So you can use a diode as a switch. I have a ham radio full of this kind of switching, and yeah, this same negative tone charges the AGC line, opens a squelch to allow transmitter audio to operate. Wow. Okay, I'm reading this, but it's not fully going into my head. And a little more. Antenna switching. The relay transfers the antenna from the receiver input to the transmitter output when the microphone switch is pressed. The relay is actuated by cathode current of the power tube and V8. I think it's the oscillator, transmitter oscillator tube. Intensity of the red light increases with modulation. I haven't really looked, but I'm sure it's doing that. Well, so this hasn't given us any hint as to what that capacitor is doing. Well, the most I can say is it better be 8 microfarads, because that's what it says here on the schematic. That's what I'm down to. Don't know for sure what this guy's doing. Oh, hello! What are you hollering about? I've been in the shop too long, that's what he's saying. Okay, so I think the next step with this capacitor is to try to determine, is it an 8 microfarad capacitor? Is it fine? How can we do it? Just put a capacitor tester across it in circuit. Why would that not work? Because there's a low resistance short right across it. Maybe not. Now put an ohm meter on this, find out what kind of resistance is paralleling it, if any. And if we're lucky, it's high, and I can go ahead and test this right in the circuit. Okay, that's the plan. That would be the plan here. First, we're going to measure the resistance across it. What happened here, cats? Want to go in here? Yeah, go ahead. Go in there. When it gets cold in my house, we start closing some of the spare rooms off, and cats, they like to go in those rooms, so that's where he's gone. Right, we're doing a resistance measurement here across the capacitor. We're not trying to read through the capacitor, we're just interested in what kind of parallel resistance there may be with it. I suppose logically it can't be much, can't be very low with a large capacitor. I think those two things don't go together. So I'm seeing open circuit here right now. Can you see that? Yeah, you can. 20 megohms. So it's more than 200 megohms across this capacitor. Wow. And that suggests, that alone suggests it's in pretty good shape. Just check my meter here. Yeah. 0. Okay. So that says there's a very high impedance across it, and we can probably easily measure it. Now the test leads I want to use, what was I doing with them just a while ago? This is a large capacitor, so I can test it with long leads onto my capacitor checker over here. This is the capacitor checker. Just warming up. It's a polarized capacitor, of course. Ground. So the first test I'm going to do on it is leakage test. So I'm going to put 25 volts across it. That voltage is free to travel in the radio, but based on the resistance test, I don't think it's going anywhere. This tester will test regular capacitors and electrolytic. I have the switch set to test electrolytic, something I'm forever forgetting. 25 volts on a 150 volt capacitor. So the eye should, there we go. The eye should snap closed and then open fairly quickly, I think. Open up as wide as it is now, or even wider. Much wider. Very, very fast. Okay, we'll put it on 150, which I think is the rating of the capacitor. It's going like a bullet, okay, which is not exactly a good sign. This capacitor should take a bit of time, I think. So I'm just double checking my test leads here. Okay, back to 25 volts. Just instant. It really looks like that, doesn't it? It looks like this capacitor has 0 capacitance. Fat chance on that. Fat chance on that. So we'll try measuring the actual capacitance. Okay, so it's supposed to be between 0.1 and 50 is where we should be. 0.1 is this second scale in radio. 0.1. So 50. 5, 10, 50 is way up here. Let's go on this other scale. 20 to 1,000. Maybe we'll try both in here. So 20 is the inside scale, right inside here. So 20 is right here. So 50 is almost where it is. 50 is here. This should open when we cross this 50 mark. 50? Where did I get 50 from? 8. What am I doing? I lost my head. So we can't do it here. What am I talking about? Back here. Okay, here we go. 8. Get it in your head. 8 is here. Oh my gosh. There's just no. Now, when you get a response on this instrument with the dial set all the way to an extreme, it's really not worth paying attention to. Let's go smaller. This capacitor. Okay, so it is in the circuit. I'm not reading anything. That's really very surprising. Next step with this capacitor then is to open one leg on it, so it is truly disconnected in the circuit, then test it again. So I have my choices here. Make sure these were done right. These are definitely done right. Right polarity and everything. Okay, I don't know. It's just, I'm stunned. Mostly I find these capacitors to be pretty reliable. These metal clad electrolytic ones. So lots of extra wire here. So I'm going to nip it right close to the connector there, and that'll preserve enough wire I can retighten it. They seem to have run the wire as much as, like they could have shortened up this wire, made it go straight across. And maybe they're just worried about this bottom of this capacitor. Maybe that's what they're worried about. Or maybe they gave it zero thought. And there's no reason why I should either. Okay, we'll pop this guy off. Cut him flush. Oh, I got 2 wires in the grip there? I think I did. I want to cut 2 wires. Okay, let's just put the capacitor checker right back on it. Gee, I wonder if the clip lead wasn't making electrical connection on the wire here. There's too much. Yeah, no, I had it on the connector, so that shouldn't have been a problem. Okay. So we're still measuring capacitance. Let's see what we get now. Oh my gosh. It wants to open way down here. That would be 0.1 to 50. 0.1. Well, that's way off. Let's put this. It's supposed to be 8. 8. This is the only range that has an 8. The 8 is up here. Well, this tester is telling me this capacitor is bonkers. Let's try another tester. Another capacitor checker. I bought this instrument specifically because it had its own capacitance. Now most of these meters do have the ability to check capacitance, so I don't. For some reason, the regular multimeters, I don't like using the capacitor checker. They're really intended for more modern stuff, of course. I mean, what isn't intended for more modern stuff? Okay, on the so it's a 20 microfarad scale. This is easily within the range of this meter. My gosh, it's telling me nothing also. So what's happening here is I'm getting a result that I just don't want to believe. I don't believe it can be a 0. Negative, positive, LC for sure. This is done right. I got the dial in the right. Once in a while I put these dials you can turn right backwards because you missed a little tiny marker dot there. No, that's not the case here. Dead as a doornail. It's got nothing. It's offering nothing. Oh my gosh, like really nothing. So now we're getting close to the range of the leads, the capacitance of the leads itself. My gosh. Well, I can be nothing but convinced here, really, that this capacitor is absolutely kaput. Kaput. Ah, I can't believe it. Ring the bell. Let's get it right out of there. Take a closer look at it. Let's take a look at this guy and see if there's something about it that would raise our suspicions about its condition. First, let's just make sure it's what we think it is. Eight. Can there be any doubt? 150 volts. Now, I did notice in looking at it in the radio that it appears a little swollen on the ends, but then that's like a shrink plastic material that has, so I don't think the capacitor is actually bulging. For a capacitor to test absolutely dead like this, I would think there's a fault in the lead somewhere. Literally, the capacitor is disconnected inside. Well, these are all feel pretty stiff. I don't see any movement. Somehow I'm still unconvinced. I am unconvinced. What more can it take, Jim? Now watch it test good this time. Okay, I'm able to really rotate and get some good contact in here. Now if this thing tests good, I'm going to cry. Okay, so it's supposed to be an 8. It looks more like a 0. It's just absolutely convincing. Convinced of the unlikely. Man, okay, I'm going to have to reset my opinion about these capacitors. Let me get an 8. Stick it in there. Okay, so I've got a 6.8 here, which I'm sure will do. It's going to do better than this nothing, that's for sure. Excuse me. And I also fished out a 4.7. I'm anticipating changing this one too, so getting pretty low on these capacitors. So first thing, I'm going to test these capacitors to test my test. Test my test. It's supposed to be 6.8. What do we get? Well, look, you can see. The meter's definitely working. There we are. Okay. I just still can't believe it. He's so good looking. Okay. Now this is a little short to do the job. I'm going to have to extend one of the leads. So I'm going to install this. I won't bother doing it on camera. Just get it installed and move on. Well, there's a shot of my fireplace, just in my rec room, a little distance from my shop here. And you can see the fire's not going so well. It's kind of gone out. You can see a little glow down here. So I'm going to keep an eye on my fireplace while I'm in here, because what's happening is I'm not stoking it enough. So that's why I'm looking at it through this camera here. In a little while, maybe she'll be roaring again, because it's very cold here today. Okay, one done. Here it is here. And now I want to go after this 4 microfarad one. First we'll check it out on the schematic and see what we can see about it. So that 4 is located, there's a 10 on there. I'm trying to remember where I saw it. Where did I see it? I have to go through the whole process of hunting. It's electrolytic, so it should be pretty easy to spot in here. Yeah. 10, 10. Okay, I'm gonna have to. Okay, let's look at the diagram. Let's look at a photo here. says C28 A and B, but on my radio it's two different capacitors. So C28 A and B, that's what we're looking for. How's that help? C28 A and B. In here somewhere. Okay, so the one we're after is up in this area right here. Zoom in. Let's see, what's it doing? It's on the plate circuit after a large resistor here. 50. So pretty far lie here. So this is on the transmitter audio. So the audio is coming from the microphone, being amplified by the triode here. The V10, yeah. So the cathode current is part of what's going through the relay coil here. Not that that matters. Audio. So there should be a strong audio signal. It's either being tapped off here. Let's follow this. See where it goes. Ooh. Okay, don't get lost now. We're right above V7. 2 lines above V7. Here we are, 2 lines above V7. All the way over here, down to here. Sure looks like audio. Yeah, second. Here we are, second audio amp. So the output here is, let's go back up here. Output here is just audio coming from the microphone, having been boosted by one tube. What? Well, this is a pretty large capacitor to be sitting in an audio circuit like this. So I don't know exactly what it's doing again. I could take some guesses. It's attempting to remove any audio signal that's left in this, coming on this line. So the audio wants it to go this way, but doesn't want any audio coming down this way, any audio signals. Where's this go? This probably just goes to the power supply to pick up the B+. Sure enough, there it is. Picking up the B+. 335 or 360. 360 received, 335. That's got to be what it is. It's just trying to make sure no audio makes it back. You don't want accidental signals traveling on what should be DC supply lines in the radio. So that's got to be what that is. But what would happen if this isn't working well? Well, you could get some kind of feedback thing going, I would think. Hey, this radio did have a feedback when I turned the volume really high on receive. It did some feedback thing, but it shouldn't be through here, I don't think. This part's cut off when you're in receive, I think. Okay, well, I got a pretty good idea of, 100% idea where this capacitor is. Exactly what it's doing, I'm not 100% sure. You know what? Look at it. It has something to do with this side too. Again, so the cathode's grounded here. So where's the output from this triode? Back through here? I guess so. I don't know where else can it go. I mean, these two plates are virtually tied together. Looks like it. Looks like you got microphone audio through here, radio audio through here. Both of them work their way onto this wire. Any leftovers get killed by this capacitor if it's in a killing mood. So that's what we got to do. We got to find out if this is a killer for microfarad capacitor. Okay, I think I'm with it. So right away again, basic questions. Is this capacitor still for microfarads? Well, I had a lot of faith in this metal one. I don't have as much faith in one of these, but let's check it out. So first we'll make that resistance test and see if if the resistor shorted, I mean, I would see that on this meter. But I'm really wondering about the resistances around this. I could have looked on the schematic a little closer for that. Because there are quite a few resistors all around it here. So just a resistance test. $200,000 ohms. Well, I don't think that's going to interfere with a testing of the capacitor. 200,000. Let's try the capacitance meter here. I could have done it with that other one, but I like this one better, as I was explaining, for no good reason. Negative there. Positive here. What does the capacitor say, Jim? It says 5.5. It says 5. It's supposed to be 4. My experience is with capacitors that read high on meters like this, it's because the capacitors are a little leaky. That's been my experience. This guide tells us 5. Let's just increase the tension here. We'll see what the other capacitor checker says. Still in circuit. Maybe I will personally, before I hit the switch on this, put some electricity into this radio. I'm going to, during the capacitor test, I'm just going to take a peek at the schematic here. So one way from the positive lead, it basically takes you through 250,000 ohms to the plate and then on that long wire that goes somewhere. But to get to the long wire that goes somewhere, you got to already go through 250,000 ohms. The other direction is right away, 220 ohms, and then you're into the all over the place in this radio. I don't see that we can't test this. A couple 100,000 ohms around it. Okay, man, let us do it. We're hooked up. We're ready on the 25 volt scale. Now that behaved just the way I would expect it to. Not as fast as the other one. There's just a slight delay in its opening as it charges the capacitor. The rating on this one is 350 volts, so we can easily go 150. So this is showing no leakage. Showing it to be in good shape. Then we'll now try to measure its capacitance, which was 5 on the other meter. Three, 5. That sounds like 4 in the average. No significant leaking. And on this guy, it's measuring 3. Now you know what I have? I have the potential replacement here. Let's put it on. It's brand new. No reason to doubt it. 4.7. No reason to doubt this. Okay, let's switch. See, now this is more or less a check of this instrument. Oh, this capacitor, it's not opening it. Are you serious? So that indicates a bad capacitor too. My brand new one. What? And it's right in the same spot. So right in the same spot, it probably means the capacitance of these two capacitors is the same, but something's going on with this one. Is it leaking? I got this on backwards? No? I got the polarity right? What's going on with my nice new capacitor here? Here we go. That's fine. This is a 400 volt capacitor, I believe. And good for 400 volts. So it claims. Let's give it 150. That looks good. 250. It's getting there. So why read the way it read? Why not pop this eye open properly? Let me put shorter test leads in here, just in case. These long leads are doing something. This makes a difference. I'll be very surprised. Okay, so we'll come off here and we'll go back to the 0.1 to 50. Now, can you even see that? You can't even see what's happening in the camera, so I apologize for that. But instead of opening, it just gets a little bit darker right in the area where it's supposed to open. It will not open though. What kind of capacitors have I got here? It's really kind of disturbing. Totally disturbed by this result. How can this be? Now, I don't know if I got some more little guys. I think so. These are really small capacitors. Here's another one. Now they're 6.8. 6.8. Can't believe I'm caught doing this now. Negative to negative. Positive to positive. Make sure I'm positive about that. 6.8 should be up in this area. Same thing, it's just dipping a bit. Why is that? Makes no difference. I really don't know. Maybe it's because the leads are shorted here. No, they're not shorted. What's going on here? Maybe my tester's no good for small. This is a 47 microfarad one, 50 microfarad. Brand new again. These are not old stock. So 50 is going to put it way up here. No, yeah, 50. So you see it opening a bit there? Can you see it? Yeah, you can see that. So too close to the edge, so I change scales 20 to 100. Look for another opening. There it is there. Dial it right in. And what do we get? From the 20 to 1000, 30. 30. It should really be reading way up here at 50. I don't know what to think here. Never had my these test instruments conflict. Battle of the meters. Who can you trust? So this is a 47. Who can you trust? Looks like you can trust this meter. 47. Oh, don't tell me this guy doesn't work well. Maybe on reading the capacitor sizes, it does. There's no maybe here. It has internal capacitors that it's using in a comparative way. And if the internal capacitors are mucked up, maybe this is the kind of result I'm getting here. So this is right on. Let's try in these small ones. I always like it when the vintage stuff works better than the new stuff, but you know, it's a bit of a... So this is supposed to be 4.7. Look at that. I think I know which tester I'm going to rely on. Uh-oh, this means, what about that? I did that. I did the dud with this. Let's do it again. Oh no. Oh no. Negative here. Positive here. Yeah, I'm willing to bet it's a broken lead inside this capacitor here. Or corrosion. Okay, the lead could have corroded right inside. Trying to get, you know, wiggle the leads, get any kind of response. No. Okay, well, there's no doubt this thing has no capacitance for reasons unknown. Also found out that the accuracy of making capacitor measurements, at least electrolytic ones, very questionable here. Never experienced that before. I'll switch this back to regular capacitor types. Have to experiment some more with this on another day. Sort it out. Turns out this guy I think is extremely reliable. That's the impression I'm left with. And so I measured this at 5. I also checked it for leakage, no leakage. So I think I'm going to leave this guy in. Now, there's another set of electrolytic capacitors, but these are oops, up there, up in this metal can here. Again, my experience with these is that if they're in the metal can, they're usually pretty reliable. And they are sitting right there. Looks like 3 terminals. There's 3 different capacitors in there. 300, one and a 20. It has a 300 volt, a 150 volt, and a 25 volt capacitor. And the sizes I can't quite read on the can, unfortunately. So that means there's 3 live tabs. The ground must just be the capacitor fused to the chassis, which it is. So we're going to try to measure each one of these capacitances. Capaciti, would that be the plural? Capaciti? Capacitances. Ground this. Okay, I can ground it right here. And I'll stick it on one of these. You just ignore the fact that it's in the circuit, and the radio's not been on today, so there shouldn't be any charges anywhere in here. Charges in here. That just reminded me of something. So this is I don't know what. We'll put this on 20. It's over. Well, none of them were 16, I don't think. 16, 15, 16. Next one. Another 15. Last one. So it's measuring capacitance on each one of these. These capacitors are doing different duties in the radio. I think one of them is right in the power supply. I think it's an 80 microfarad capacitor. Let's see if I can just... I cannot read it. So, I mean, what are the chances that this capacitor is really messed up? No, there's no way I'm going to be able to get in there and read it. It's just not accessible. It's not eyeball accessible. If trouble in those capacitors, so there's 3 of them there. That's number 33. Let's find all 3 on the schematic. 33 A, B, and C. And let's do that. So I found them over here. So here's 33. Here's 33A, and that's across. That's across this. What's involved in the squelch thing too? Supposed to be 10, and I measured. What I measure 11, 14, and 14. Here's a B. It's another 10. It's another one across the. I It's another cathode resistor bypass capacitor. Here's number 3 right over here, 15. And it does kind of line up with my measurements of the capacitance in this thing. What's this one doing? This one is quieting the screen on the modulator tube. You never really look closely at the modulator and how it works. Something I want to do at some point here. So let's see. Squelch, it seems to work, although most squelches are a little more sharp. This one's got a bit of a fuzzy switch, if you like, as it switches from, as the squelch comes off, or however you want to put it. That'd be because of this guy. This guy's job really is to bypass all this stuff. Squelch is 1/2 squelch. The audio from here comes through here when this voltage is allowing it to. You can change it here, or it will change due to the throughput on the cathode here. The second audio amp. You see more audio comes out of the radio, gets rectified up and away up there, and sent down on this line from that other tube we were looking at. This causes a signal. It's not going to change the DC current through here, is it? I don't know. You got me as to how all this, exactly how all this works, I don't know. But you can pretty much clearly see I don't know. Note 4. Quick, let's read note 4 quickly to note 4. Varies with squelch setting. Note 4. Varies with squelch setting. Squelch. So that's just a voltage or something like that. Where's note 4 go? So note 4, 75 to 1. Varies, so that's a 75 volt range on here. And when you go to transmit, 85 volts comes on here, cutting this off. It's got to be what's happening. That's a lot of volts on a grid. Okay, what about this? So with the bypassing, if that's what it is, it's bypassing this or all this stuff down to this ground here. Actually, would be over here maybe? Bypassing these two guys. And this is your typical cathode resistance size. This is not, 47 is not, but 2700 is 15K down here. I don't know how this is working exactly. If this is weak, we don't get as much. We're letting something through that we don't want to let through. Here, going back, and you get feedback out of this. You could get feedback out of this. Yeah, because you're supposed to be pulling this down to the chassis. And if you're not, you get a little bit of action in here with the signal, and it's going to get a little bit of action all the way back up to the grid again. So the high volume feedback might be due to a weak guy here. That would also, if the signal is passing through this resistor, it just reduces the output of this amplifier, I think. You know, likewise over here. And so 5 volts. And this one, which is trying to quiet the screen and get rid of anything that might be on there. Of course, it's sitting here, it's going to have an effect on all these wires here, all these lines. But they're showing it here on the schematic, probably because they want you to relate it to the screen. Not like they could show this, you know, they could show this way down here. It'd take a long time to maybe figure out that it's really about this. What's that little square there? Oh, so on the capacitor, there's a square marking this terminal, a bar marking this one, and a triangle marking this one. Can I see those? Now often when they install the capacitor, those hints get covered up under the chassis. Let's take a closer look here. The conclusion I'm drawing to on this big capacitor is there's nothing wrong here. Nothing worth me fiddling about. Close-up camera. Right. Jim, close-up camera. Must be getting close to lunchtime here. Close-up camera, not close-up. I'll make it close-up. So we're trying to read. The radio is off. Trying to read what, or see squares or triangles or a bar. And you see, there's nothing visible in there at all. They're probably hidden under the chassis. So that's not going to help us. And what do we need help with anyway? I'm not sure we need any help here because I think that capacitor is probably good enough to stay put. Good enough for now. I don't have any reason to really get in there and go at it. Now, the next two that we really want to, might as well take a look at them now, is this one, this 0.1, and the other one that's buried down under there. 0.1. And we still have this bumblebee one too to check out. Let's where am I on the clock? Hey, you know what? I think I'm done for the day. So what we've done is we've checked out the 3 electrolytic capacitors in the radio. Found one, totally surprising to me. It appears to be just a dead dog, but not really performing an electronic job in the radio, doing something with the relay here, which didn't seem to have a problem anyway. And I'll leave that guy in there. I'll leave those ones alone. The next thing we'll do on the next video, we'll do these 3 capacitors and anything else that kind of comes to mind, like that thing that appears, I was going to say appears to have a burned end on it, but it's just a shadow from a wire. Okay, we're done. Thanks for watching.